explain it in a way that ordinary ham will be able to understand it and see that, oh wait, this is 100% copied code. So, N6TGGG says no sound. There should be sound. I'm broadcasting sound. Does everybody video? Okay. Well, no, I'm broadcasting it. It says it's going out. So check your. Well, there you go. Looks like people are getting it out. So for people joining, this is Brian Fields, amateur radio sign W9CR, and I have no idea what that means. I am following along on chat. I'm scattered a bit. I apologize for that. So I'm going to go through some of this small part of code that we found with some of the copyright between AllStarLink, Jim Dixon. That has been 100% stolen. Even the very most basic ham will be able to look at this and say it's the same thing. Hold on. Okay. There we go. Excuse me. Well, I know you need to turn your computer up. I'm looking here. I'm set up right on my mic. I don't know what to say. We should be good. I'm peeking out here. I'm hitting. So anyways, let me pull up my presentation. I did try to do some PowerPoint or something so that people can kind of follow along and go through some of this. And presentation is pretty basic. It's called Who's Your Daddy or Who's Your DAHDI? An examination of VoIP theft. So we've We'll see if that makes a difference. See if that makes a difference. You got audio? Do you have audio? Okay, we got audio. That's good. Good. So, like many things, I'm having to unplug. I'm using a Sound Blaster USB audio card. And I had a disk get reconnected a couple times. Seems like it's working now. So I thought it's funny. YouTube doesn't pop up and say, "Hey, there's no problem with your connection," or it says it's great. You have audio. So and okay. So I think I'm ready to go here if everything's working. This worked pretty well last time. And I don't know why it's choppy, guys. It should. I'm Let me try restart OBS. Okay. Should be back here, guys. So we should be working. If it's not going here, it's an issue with bandwidth of YouTube. It's gonna be my ISP that just can't handle the bandwidth outbound. It was just this is the exact same stuff that I've used before for doing this, so it should work. But like I said, I'm monitoring the chat here. And since everything seems to be going now, I guess the OBS start did it. We're good to go. So I did a presentation here. No, I'm not on an ISDN connection. I'm on a cable mode, and unfortunately, in the United States, there's one provider in most areas for cable. Mine happens to be Spectrum, and the only package they offer is a 2 meg up, 20 meg down package. That's what I've had for the past about 15 years now. They do not offer anything else out here. There's no other pair to go with. So that is what it is. I should be guessing 1.5 that's having problems. I mean, it's showing that I have audio coming in and going out. I don't get this. The only thing I can think is I have bandwidth available right now is on my cable modem. I might have to schedule this. It is 7 p.m. here, which is going to be prime time. Cause number is. Do you hear audio? Should be working. I'm going to take a look at my my network here. Here, 1 second. Only thing I can think is it might be some network issues. I see quite often on Spectrum now, since they've shut down all their peering. They used to have BrightHouse used to have a whole bunch of peering over in Tampa, and yeah, packet loss. It's probably going to be Spectrum, which sucks. I really can't do anything about it. Well, somebody says they hear audio hiss. I don't know if that's a good thing or not. It's a complete reboot, and of course I had to restart every damn little thing here because there's like 5 things I'm presenting all at the same time. And so, Eric, you can't hear me. Okay. Let me see what I can do. Okay. It's not buffering. It's not doing anything. So I've done 3 things. I rebooted. I swapped all my packets to go out my router in Tampa at a data center rather than out Spectrum here. And it just so happens Spectrum peers directly with that facility, or at least they did. So there's probably a little more latency on it because I'm going through a VPN, but welcome to the United States of America where you can't get good internet service at home. Okay, so if somebody wants to maybe throw out an email and says, hey, it's working now, the idiot fixed it, that being me, that'd be awesome. So, I'm sorry, guys. I don't know what it is. Let me know if it goes sideways again here. We're going to hopefully see if this has fixed it. I'm going to stop this. Let's see. Andrew, I wish I could get gigabit here. I would gladly pay for it. But again, the only thing they offer is a 2 meg up, 20 meg down. It's the same thing they've had here. When I call them and I ask for something better, we don't offer it, unfortunately. So, anyways, so my presentation, let me get into this. I'm going to have to cut this down eventually. But it's called Who's Your Daddy? And let's see if this keeps working. Yeah, man, it's rough. I'm out here in the most populous county in the state of Florida, and there's one provider. Well, I could get DSL. I can get 768K down, 128K up DSL because it's not a real central office, and that's Frontier. So, a little bit of background here. Now, this is where we lost it last time, which was AppRPT. It's a plugin for Asterisk. I think we all know what Asterisk is. And, WISP is even worse. Most WISPs are just horrible when it comes to being... the WISP, you talk about oversubscribed and undercommitted. That's a WISP. Or overcommitted, I should say. So anyways, AppRPT. It's a plugin for Asterisk, and it's what does our repeater controller and our functionality that we have as part of this. So Asterisk is this huge program that does conference calling, SIP. It supports all these things, very, very modular. And Jim Dixon, writing a lot of the Asterisk code, wrote AppRPT for ham radio. Now, what people may not realize is there's another part of this that does hardware interfacing. It's called Zaptel. Originally was called Zaptel, short for Zapata Telephony. The initial release that Jim did of this was actually Zaptel under FreeBSD. It was his choice of operating system originally was FreeBSD. He ported it to Linux, got it going, got the driver stuff going pretty quickly. I think there's actually a Linus Torvalds quote on kernel.org, the mailing list saying, wow, somebody's really designed a truly crappy card here for T1 interfacing. However, it was cheap, and it worked. It used the entire CPU and the entire bus speed of the ISA bus to do it, but it worked. And that was Zaptel. Well, we combine that with the radio interface now because we have this hardware interface and we have this software interface. Essentially, your Zaptel is your driver. DAHDI is your drivers. And so when I say Zaptel, I mean DAHDI. DAHDI is the Digium Asterisk Hardware Abstraction Interface or something like that. It's some kind of backronym that they came up with, much similar to like, GNU's not Unix or whatever. So combine that with radio and you have AllStar. Zaptel became DAHDI, or DAHDI, whatever you want to say. We're calling it DAHDI here because it works better for my bad pun. But the namesake of it was Emilio Zapata. He was the revolutionary of Mexico, and I thought I think he's on the $100 bill in Mexico, or the 100 peso bill, but unfortunately all I have is this guy here, which is a 200 peso bill, so that doesn't really help. But he is on there. So Jim designed basically all of this. All the low-level stuff initially was him, cobbling it together, getting it going. And here's the original app RPT flow state diagram circa 2004. Essentially, the big thing I want you to take away from this, if you really want to understand how AllStar or app RPT, and let's say app RPT internally here, how it all works, is you have your, essentially you see your inner asterisk exchange protocol, which is your links between nodes, SIP, telemetry process, and so forth. And all this generates PCM audio, and it goes through a summer. That's the big E-looking thing. That's the sum, and that's basically a conference bridge. So all app RPT is a couple of conference bridges chained together. I mean, it's a lot more than that, but essentially that's how it works. Now, in the older versions of Asterisk, which this is based on, keep in mind most of what we're running is going to be Asterisk 1.4, which is ancient. It's like 14, 15 years old at this point. Timing alignment is super uber important. So to make good timing choices, originally, long time ago, older versions of Asterisk didn't have that. You either had to have a piece of hardware, a Digium hardware or Zaptel, something that was giving hardware timing to the bus, or you had to run another module to provide it. However, on Intel, the whole timer interface under the newer kernels, DAHDI has moved forward. You don't need that anymore, and that fixes all the timing issues. That's why we've really favored Intel-based computers, or AMD, whatever you want to say, over some of the embedded platforms, because you just get that natively. So, issues on ARM. And when we talk about ARM, we're talking about the Acorn RISC machine, or it's a couple of guys. It's a group out of the UK that has come up with this architecture. It's a really low power architecture. It's designed for cell phones, designed for systems on a chip. And this is where we get the system on a chip thing for the Raspberry Pis and the various boards that are out there. So Asterisk, newer Asterisk, so like version 13 of Asterisk and 14 and newer run really well. That's because we've changed a lot. There's a lot of stuff that's changed inside Asterisk, and your hardware interfacing for most people that are running on a Raspberry Pi with just Asterisk is like a phone switch. Well, they're doing software-based stuff. They're not really using a hardware interface on the Raspberry Pi. And why is this? Well, it's because of timing. Intel, as I mentioned, has this fixed, and one of the issues you have if timing is not right, you get stuttering. Much like our audio issues we had initially here. Things don't get aligned properly, and essentially you have all these buffers coming in, and you have to be able to synchronize them and align them. That's a completely wrong way of talking about it, but it's very simplistic. And again, this presentation is designed to show this in the most simplistic manner so that people can understand what's going on here. Because if you're a programmer, I'm preaching to the choir and you already get this. So some of the first things that happened is Jim came out around 2011 for this BeagleBone board, which was a TI processor. I think it had 256 mega RAM. N7PKT helped them out with this. And they had this, they called it the LOX interface, because it was the bagel bone, and you put locks on top of it. It was definitely a Jimism. Yeah, there was a very good reason for it. So it was called the LOX interface. Anyways, that was kind of the first non-Intel-based machine, and that worked really well because it had some of this hardware timer stuff in it. A little bit of history of the Raspberry Pi. 2013, keep in mind the Raspberry Pi 1 B Plus came out. Man, this was a single core ARM version 6. It basically ran like ass. BeagleBone Black came out. 2013, gigahertz ARM version 7. Still a single core processor. But, oh yeah, the PCI radio, I got like 3 or 4 of those PCI radio boards, by the way. 512 meg RAM works well. I/O isn't a factor. That's a big thing because as we look towards like the Raspberry Pi 2, hey, it's quad core, giga RAM, looks like it's good, but it's got some issues with USB because the way that you have to run USB in a 1.1 mode to get stuff to work. Really, and well, this should be 2016, not 2106. The Raspberry Pi 3 came out, much more faster processor, worked very well. I/O is redone on it. So really, Raspberry Pi 2 was kind of the first contender where some of this stuff started working. And this came with something called Arch Linux, which is a real pared-down version of Linux. And Anthony, VK2, and he's since changed his call sign. He ported a lot of this stuff and got Zaptel and DAHDI running really well. He's like, hey, it's been stable. Go to my my GitHub. It's up there. And I think a lot of the responses, hey, that's really cool that you were able to do that. So this is his GitHub, and there you go. He's changed his call sign to VK5QS. And well, there's a whole timer interface, Andrew, for the. It's a kernel level thing. I won't get too far into it, but essentially he got this going, put it out there. I'm like, that's pretty cool. So around this time, a lot of people started asking, especially Doug, WA3DSP, started asking on the email list, hey, I've been doing Pi for a while on IRLP with great success. Runs without a hitch. Granted, IRLP is a considerably different animal. So I think I can get a USB sound fob and standard ILP controller board. The Pi GPIO drives the IRLP controller in place of the standard parallel port. Could a URI adapter equivalent, work here, and would it work for AllStar? I have experience with Asterisk, and goes on. And so this is 2013. Some of the first people asking about it. And then the other thing that came out was an updated version of the BeagleBone called the BeagleBone Black. It's a smaller form factor, similar to the Raspberry Pi at the time. And hey, it's like a third the price of the Beagle board, which was a much bigger computer. And it looks like it has same capabilities or better. So funny, you fast forward to 2014, middle of June, Dave and Doug release a package for the BeagleBone Black, and they call it the official AllStar release. You can see what it says here. I've gone through it, and it's very detailed. Basically, what they did is they took Arch Linux that had already been ported, some of the other code that was out there, packaged it up and put it out there and says, hey, this is official AllStar Linux. Well, you can see what the dude said about this, Jim Dixon. It says, hey, it has quite sadly become painfully necessary to officially and publicly state that this is not any official AllStar release. It has not been sanctioned by me or the AllStar Network. It is something that this person is doing completely independently. And he's saying, hey, I'm not trying to say anything is right or wrong, just that it is independent and it is not AllStar. And you can see David's acknowledgement of this. It came back, well, I think Doug probably meant it's officially released, so I'm going to backpedal a little bit there. We've been beta testing it. I'm not surprised by your comments, but I am disappointed. He goes through a little bit further. But at the end, he does acknowledge, he's like, rather, you have to embrace it and direct it. If the system works reliably and interoperates with AllStar, what's the problem? So at least he says, hey, we know it's not AllStar, whatever, mea culpa, or copla, whatever you want to say. So we fast forward to the present day. This happened 2019, September 24th, September 2019. Got an email from Skylar. what is his? He changed his call sign recently. I don't know his new call sign. I'm sorry. This is an email that he wrote to John David McGough of HamVoIP. He says, "Hey, DAHDI only runs well on the Raspberry Pi, and I noticed it's got this DAHDI HR timer module. What does this do? How is this written? What is the reason without this? The Raspberry Pi has unreliable audio timing versus the normal computer. Other audio applications, video streaming, seem to work fine, so, why'd you have to write this? Not to mention that if you are running a kernel module, especially something that's going to link into DAHDI and the Linux kernel, it has to be GPL version 2. Which means it has to be open source. Otherwise, you get what's called the tainted kernel. You can't really do that. It's a whole. I'm not going to get too far into that. There's all kinds of stuff out there about the Free Software Foundation that they've put out regarding linking stuff. But essentially, if it can't run on its own, it's a derivative work. So this is John David's response. He says, "Skylar, I've spent literally hundreds of hours fixing timing issues in AllStar. Too much to even begin to describe in an email. Oh my God, it's so complicated you would not understand it." That's essentially what this is. I really don't like that. I think anything, is simple enough with enough eyes looking at it. So he says the HR time driver was cobbled together by me. Okay, and it is one part of all the fixes that he's done. But again, we're not going to get detailed here, even though Skylar is somebody that would understand the details. It's just too complicated for somebody other than John David to really understand it. And that's all you're going to get from him. I don't like that attitude at all. So let's take a look at it. I said, yeah, let's. It's been a while since I've booted up HamVoIP. I did this back probably 3-4 months ago now. Let's look at the kernel modules. Okay. This is running on the HamVoIP code. I set up a number of, you can actually see my setup right here. Whoop. There's all my Raspberry Pis that I use for testing. I can just plug in and go from one to the other. So you see it comes up, and we got this DAHDI HR timer module. And there is no data I can find on this HR timer module anywhere. Nobody knows what it is. So we actually do some DAHDI testing, and you can see, hey, our audio is really good here. That's actually really good most of the time on the Raspberry Pi, and it is quite frankly perfect. Most of the time on the Raspberry Pi, it's like 99.2, 98.5, something around there. Yeah, it works reasonably well, but it's nowhere near this. This is like it's got real hardware in there. This is something I see on my Linux machines under Intel, or some of the ones that have the PCI radio card or the asterisk. I still have a couple of analog interface cards actually running. So let's just, for shits and giggles, we're going to remove the module, DAHDI HR timer, and do another test. Okay, we see, yeah, that's kind of normal for the Raspberry Pi. That's what happens. So that is fixing the timing under Raspberry Pi. Interesting. But let's take a look in, the Proxys kernel tainted module, and it comes back. Comes back with a bit assignment value, and here's the link here. You can go look it up. But bits 10 and 12 are set. That just means it's not a mainline kernel module that's compiled. It's something external to the kernel tree, which we know that, and that the other one was bit 12 means something else. But basically, the one that says, hey, there's non-GPL code in the kernel, that's not set. So this has to be GNU public license, right? So under Arch Linux, or HamVoIP, it is, here's the link to the module, to the kernel. You see it's compressed. So we unzip it, and let's throw it through readelf. Readelf, anything that's going to be under Linux uses what's called an ELF, or extensible linking format, similar to how Windows uses a portable executable linking format. for Windows. It's just a different exe. So there's a modern operating system takes code in, loads it, and has to know where to put it in memory, how much memory it's going to need, various things. And that's this ELF header. So what you get on this, and you can see what comes out here, is a whole bunch of information, what it was compiled for. Is it Big Indian, Little Indian? That's a byte order issue. The machine it was made for, in this case ARM. It's relocatable, so you can move it around in memory. Pretty much everything like that's going to be. And then it has all the different sections, and there's all kinds of sections. There's sections for objects, sections for actual binary code that run. There's debugging information that's in this, and I'm like, oh, that's really neat. And I'm like, it's got debugging symbols. That means I can debug it and see what's going on very, very easily. I didn't even have to get that far to debug it, but I'll show that. So it says it's GNU GPL code. You can see right there, section number 1, it's GNU. And link once to say that it is GNU. The .text, which is the code, this is very important. This is 360 hex, 864 bytes. This is everything else that's in this file is header and other crap. The stuff that actually matters is only 864 bytes of machine code. And that's called the .text area, and you can see that's number 2 there on the screen. So let's strip out all this other crap and take a look at what's actually there. So I take a look at this, and this comes up. This is what's called strings. So we run strings on the file. And this is just what is text in the file. Not what's binary, just show me what's text in the file. No, I didn't run lint. I don't need to. But let's I like where you're going, though. So let's strip it and see what's there. And I start noticing. And I get a little chubby when I see this kind of stuff. Misspellings in comments. I love misspellings. So when the program has an error, it comes back and says, hey, I can't initialize the DAHDI driver. Something's wrong. Well, if you take a look here, it's initialize, not initialize. Well, that's kind of cool because now we can Google that. And I see this come back. Huh. Interesting. There is the exact misspelling in somebody else's code. Isn't that brilliant? What are the odds of that? With the exact verbiage around it. Yeah, I'm giddy. I still am giddy over this. It's funny. Okay, so I'm like, what the fuck? It's this DAHDI dummy thing, isn't it? I'm like, but that's for timing only. We don't need that on Intel because it's not neat. Oh, wait, it's ARM. Wait, that stuff that is in DAHDI, yeah, that's not going to be there under ARM because that's for Intel only. So I'm like, okay, but John David obviously built something else around this because he couldn't. He's not just going to copy this, remove the author's name, and rename the module and then just have it do the same thing, right? Well, let's take a look at the timing interface with it loaded. So we can take a look, and what happens is when this loads into Linux, it binds into the timer. There's a timer subsystem in Linux. You can look at proc timer list. Under Intel, there's a few other things, proc timer underscore, I think register, and a few other things in there. But the important one that's there across ARM is proc timer list. So basically what this does is it gives timing information to various parts of the kernel as they need it. And again, won't get this could be its own 3-hour-long conversation. So we can see number 1, CPU 0, clock 0, HR timer is loaded, and it's loaded using a function called DAHDI HR timer init. Now that's the actual name of the function in the C program. That's not HR timer. HR timer is the module name in this case. And you can see what's there. So we started looking a little further at it, and well, could we compile just the dummy driver and see if that works? Because that hasn't been compiled for a long time on ASL 1.01. So I grabbed the code and compiled it, and if you have ASL 1.01, the code is in user source. It's in that directory right there. But you got to enable it, because by default, in that file there, that kbuild file, it's commented out, because, well, why do you need the DAHDI driver after all, right? You're running under Intel. Comment it out and build it. Okay, so I actually built this on one of my production nodes, because, you know, who needs development when you have production? So built it, ran DAHDI test after putting it in there. And I'm like, wow, that's working great. I mean, it's working as good as my normal nodes are. So, okay, the dummy driver is doing it. I look at the actual kernel object now. This is the driver. And under ASL 1.01, it compiles to almost 9,000 bytes of code, 8.7K or so. So I start looking further into it, and I look and I say, okay, well, the text file here, the text of it using the readelf, this is the actual code that executes in the kernel, is 3 echo 8 bytes large. So this is a little bit bigger. I think it's right under 1,000 bytes decimal, versus it's like got an extra 100 bytes in it. Well, what could that be? Well, we're running a different kernel. We're running an older kernel. We're running some other debugging stuff that's happening. So it's not an apples to apples comparison. We can't really just say, let's take this code and compare it to that code. So maybe I can compile. Now, HamVoip does use a newer kernel. So maybe I can compile this code as DAHDI dummy driver, because I don't have the source for HamVoip, which is because they're in violation of the GPL license and so forth. They don't distribute their source code because it's way too complicated for you or I to understand. So I go and grab the code. Nate Hardman and Stacy, but Nate did a lot of the work. Actually, I think he did the majority of the work, and Stacy will correct me if I give him too much credit for it, but I want to say he did like the majority of this work getting this going. So he got it compiling on the Pi 4 kernel, some of the newest stuff. So I grabbed it, threw it on the HamVoip Raspberry Pi. It was a Pi 3 B+ I'm using, and compiled it. So I stripped it out of symbols and compared my two files I had, my two drivers. And I said, well, shit, look at that. HR timer and dummy stripped of all symbols are exactly the same size. That doesn't mean they're the same. I figure they're going to be close if they're identical, but not exactly the same size. That was amazing. That doesn't imply anything. I'm just saying it's kind of cool. It's like another nail in the coffin. So there's another program that I use for doing reverse engineering, and it's called IDA, the Interactive Disassembler. If you do any sort of reverse engineering, you're going to have a copy of IDA. I actually have a licensed copy that I use. I'm not big on proprietary software, but it is one of the best pieces of software out there for doing reversing. The guys that are behind it, I think it's like 1 or 2 people that develop it. It's insane the amount of stuff they're able to put in there. So anybody that's doing anything in reverse engineering is using IDA. So what I did here is I looked at my readelf, and you can see this is the HamVoip code right here. This is the DAHDI HR timer, stripped of all symbols, or stripped of debugging symbols. And okay, we see what's there. We see the prog bits, and the big thing to look at is text. It's at offset 58, and it's 364 bytes. Everything here is going to be hex values, large. So I want to say right around 900 bytes of code, decimal. Here's the same thing for DAHDI dummy that I built, and well, fuck me if it's not almost identical. It's the exact same size, exact same offset. There's going to be some differentiations between compilers generally. You can take actually the same code and compile it multiple times with the same compiler, and it won't necessarily always be identically the same assembly code. For various compiler things I'll get in. I'm not going to touch on, but it's a whole thing that GCC does. Other compilers do stuff like that too. It's optimizations and the way they look at the code. So this is what I mentioned. The text, which is, again, this is what gets inserted, what gets run by the kernel, is just what's here. Everything else is supporting information. It's exactly the same size. Doesn't mean it's the same code. So here we go. Here's a HR timer. This is what it looks like when you load it up in IDA. This is IDA will actually go through here. And if you look over on the left-hand side, what you'll see is a couple module names, and this is that extra debugging information that's put into the system. Those module names right there are what are functions that are built into the code. Everything else that's in pink is imported from outside the code. This means like printf, for example. Well, it's already a function that's in the kernel, so you're not going to compile that function into your code. It's kind of a dynamic linking thing, but being this is kernel code, it's a little bit different than a normal program. The important thing here, though, is that these are all named the same. So and what I'm going to do, I'm going to get my let me get the cam off of here. Okay, so you can just see everything. And you can see right here what we're looking at is DAHDI dummy HR init or HR timer init. This is kind of the first thing that runs in the module. And if you look at this, you'll see, well, this code here, this is the assembly. This is what's running. This is the machine code running on the computer. And if you look at from left to right here, you'll see that what it's calling in externally is almost the same, and the code that it's running is essentially identical. Now, you're going to say, well, this is just one function. It's a setup function. Okay, yeah, that's true. So moving further along here, I'm like, it's the same damn code. I've kind of realized that at this point. The only difference is they renamed it and the authors were removed. So, okay, this is kind of John David's modus operandi. I've literally spent hundreds of hours fixing timing issues in AllStar. Too much to even begin to describe it to somebody such as yourself. Paraphrasing a little bit. It's one part of all the fixes. Again, we don't get actual actionable information out of John. We just get hand waving, and don't worry, it's too complicated for you to understand. Now, Jim obviously said some stuff occasionally. He's like, look, don't bug me about this because I wrote the code. Unless you're going to sit down and read it and come to me with intelligent questions, don't bug me about it. I can understand that. So, yeah, I've actually spent more time on this video putting this together, putting this research together, and solving this particular problem than I believe he put into compiling this code, because it's just stolen from somebody else. So, now, maybe there's something else in here. So let's look at this assembled code, just to be certain there's nothing hidden in this kernel module. So what I'm going to use is a program here called object dump. And we're going to look at just the compiled code, just what's running in the operating system here. And let me get my guy off the screen here. Okay. So what you're going to see on the left-hand side of the screen is very simple, DAHDI HR timer stripped. Here's the disassembly of the text. And you're going to see the same thing on this side, the disassembly of the text. And there's going to be some stuff that maybe uses a different register occasionally here. But here's your initialization. And I'm not an expert in ARM assembler by the, not even that great in Intel, but ARM is something I've never really messed with. Actually, I looked some of this stuff up. And, here's one where it's setting a initialization bit on the CPU. It's doing, branch, doing a load in at 3C, putting what's in R4 into R0. And essentially, the important thing to look through here as a non-technical person, you can look up all this stuff if you want to look it up and see what it does. This is it. This is a very low level. This is actually the hex code you can see right here that's in the file and what it compares to what it's actually doing in the CPU. Now, what's important to talk about here is the way that most way CPUs work right now is when you run a executable program on the CPU, well, you go and reference something like printf to print out information to the console. Well, your code says go to printf, and it'll have in there, oh, hey, here's the symbol table for printf. Well, when the code's actually running, all that stuff gets dynamically linked, and it's going to not say, oh, I need to do printf. It's going to say, no, I need to jump to address, 5,000 hex, run code and return. And it's just going to know that at 5,000, that's where the printf is. So you can see in here where some of those jumps happen. And a lot of that is comparing and much different assembler code than you have under Intel here. But here's, you go to the next page here. Okay. And I actually have this up on my wiki as well. I'm certainly not going to do this and not distribute what's here. But you can see, well, shit, this is practically identical. And you see, like, if you look at A0 here, load and return, it's using register 3 instead of register 2 in my code, just because when it was compiled. But then you see the next one, it's using register 3 instead of register 2. Different registers, they're identical. It's just the way the code is compiled. That's some of the stuff that a compiler does. But go all the way to the bottom of the code here. You see the code is exactly the same length. Things are, on occasion, slightly out of order. Might be one or two things happening differently between the way it's compiled. And again, I don't have access to the code in the compiler tool chain that compiled this. I'm just using what's on the HamVoip install on the Raspberry Pi. So this is identical. A non-technical person can look at this and say, yes, it is 100% identical. So let's do that. Does it do the same thing? So can I look at this and say, is it 100%? I said, well, I think it does the same thing. So yeah, it does do the same thing. So here's asterisk running under HamVoip. See, it's got this DAHDI show status, and it shows what's loaded in there under DAHDI. It shows HR timer. And it's running, and asterisk sees it. So let's remove HR timer and show it and say, oh, well, it's not there. And again, this is where we have poor performance under HamVoip. Same sort of audio stuttering and so forth. And we go to this one here, where I took and inserted the dummy module that we compiled under HamVoip, restarted asterisk, and now we can see, if you see, it says DAHDI show status right there on the left-hand side, and now it has DAHDI underscore dummy. So the only thing that has changed in this dummy module is the name, and the author has been removed. That's pretty fucked up. I mean, that's plagiarism, that's theft. That's what that is. So, in summary here, and a lot of people already know this, but John David McGough, KB4FXC, is a thief. 100% proves it. And that's, I mean, this. There we go. Got the cam off. This is him. This is what he looks like. If you see him at a ham fest, please tell him that he's a charlatan and a thief. That's what he does. I mean, like, it's cool. You want to build your own distribution or whatever. There's value in that. Cool. Keep it open source. But don't be like, it's so complicated you wouldn't understand it. I'm not releasing my source code either. And I'm just copying it from somebody else and claiming it as my own. if he just would have said, yeah, it's the same thing as, I renamed it, okay. But no, it's so complicated you wouldn't understand. That's just wrong fundamentally. So, I've proven this. There's no other way to spin this. I don't know how to look at this any other way to say it's anything other than passing off somebody else's work as his own. And it's not an isolated incident. There's like tons more of this same stuff inside Asterisk. But the reason I went after this is a very small kernel module. Does something very, very basic. It's 300 bytes of compiled code. And the average person can look at it and say, I don't know what I'm looking at here all that much, but I can see it's identical. Or identical, it's 99.99% identical. And it does the same thing, and I can replicate the same issues with it removed under HamVoIP as you see under AllStarLink 1.01. And we can fix it under both if we use the dummy module that's compiled that is open source. So his company, InitTech, Internet Technologies, if you're a customer of his, I'd really be aware of this, because I guarantee you this isn't the first time he's done something like this. If this is an open source project, my God, there's probably some GPL code. There's probably some code he doesn't have right to in stuff that he's shipping to customers. That's huge. The other thing, I actually reached out to the listed author of this module, who's the maintainer, and I says, hey, do you know what's going on here? I don't have permission to share his email. Skylar did grant me permission to share his email there and mention him by name on this. And he says, no, I have no idea about this. WTF. I never gave anybody other than Digium the right to this, and it's GPL as far as I'm concerned, because it's a kernel module. It can't be anything else. Asterisk on Arch Linux was actually created by others. Some other people did the heavy lifting to get this working, and they came by and packaged it up. Again, there's value in packaging. I'm not saying there's not. But to take what somebody else has done that's open source, that somebody else has worked hard on, close source it and say, oh, well, we've made a whole bunch of changes and, you wouldn't understand it because it's just way too complicated. That's just being a shitty person. So at the end of this, I know there's going to be some questions, but it's like, okay, how do I enable this? I'm running ASL 1.01. How do I get this working on my RPI node or my Raspberry Pi node? I have some information on my wiki. I was going to put it on the AllStarLink wiki, but they've gotten kind of sensitive about me putting anything on their wiki, so it's over there. If somebody wants to take what I have and copy it and put it over on the AllStarLink wiki, I would be more than happy with that. Maybe edit it. I put something together pretty quickly, and I know this is something that in the version that's being developed for the Raspberry Pi 4 and the new release of AllStarLink that was being worked on before kind of everything just seemingly imploded here. That was actually one of the things that we fixed in the beta release that was out there, and that's several of the guys have been playing around with it. This is stable. I've got it working, and it works pretty well. So that is, I'm going to open it up for questions now, and I'm happy to go into, let me go over to my webcam here. I'm happy to go into some stuff, and I can show some of the problems with this under IDA if you want me to pull up IDA in a Windows VM and go through it and whatnot. So is there any questions as to what all this means, or maybe somebody doesn't understand something? Let me know, and I'll see what I can say about it and see if I can help you with it. So sorry about the issues initially there. Switch over to the other cam. That was, I have no idea. I can only assume that it audio streaming got better here. So, well, let me just ask this of the assembled people here in the chat. Did audio sound good, at least in this one? Everything worked ever since we got that resolved? I'm sorry it took initially 30 minutes there to get going, but if you've ever been on a conference call at work, that's seemingly how it works too. Eric, as to how we get the source for HamVoIP released, I I would like to know. I mean, it doesn't fix anything that's broke right now, but that's its own thing. And yeah, Kevin, I know, I appreciate that you've tested it. I actually published this just kind of internally end of September timeframe, and I haven't had much time. I've been traveling for work to really document this and do some real analysis on it. There's probably 40 hours easily worth of analysis here, and putting the presentation together was 3-4 hours worth of work. It was actually going through, pulling it apart, learning about it, because when you don't have source code to something, it's really hard to say, yeah, you know what, I'm 100% certain, and that's what I'm telling you right now. I'm 100% certain this is the exact same freaking code. That's it's just shitty. I mean, fuck. So yeah, ham VoIP should really be avoided. I don't run it. Look, you don't have to use AllStarLink. You can download this stuff. You can build it. The source code is out there if you really want to do that. I actually have a repeater still running right now over in Tampa that I built the source code on Debian by hand. And you can do that and it'll work. But there's some distributions that are out there, and so long as it was open source, it was tolerated. Okay, but it wasn't collaborative. And that's what's huge about open source is collaboration between other people. You have to be able to say, hey, I changed this and did it and patched it, and here you go, and work together in like a source control type of environment. They're not really willing to do that. I've been told, oh, we're going to release the source code. We just don't want to deal with people patching it. Every time we get into it, it's more of a, well, you know what? I've made so many changes to it, I can't even really generate a patch to it because it's so changed, and it's just really hard to understand. Well, I'm of the opinion nothing's that hard to understand. What one fool can do, another can. And it's just a matter of being, maybe a bigger fool from sometimes. So, yeah, if you're doing a new ASL node, Raspberry Pi 3 ASL 1.01 works. USB radio, actually, there's some nicer stuff in ASL, especially around some of the audio filters that have been put in there. That were Jeff DiPolo put those in there. Did a lot of work to get that working in ASL 1.01. The only thing I would do if you're running it on a Raspberry Pi is you want to use this dummy module. And I got some instructions on how to do that. Hopefully that'll be part of the new release if and when whatever happens there. That's its whole other thing. I'm going to stay out of that for the context of this right now. So, yeah, app RPT running under a modern asterisk. That would be neat. There is some work happening under a 1.8 port right now, just to kind of get it there. But the issue is in the next release of asterisk, which is, I believe, asterisk 11, where they went from 1.8 to 11. Asterisk 11 basically changed the way all the conferences work. And eliminated a lot of these timing issues that they had. So that basically means there's a ton of shit inside App RPT that needs to be rewritten. Probably App RPT needs to be broken out into a few things, a couple different files, and there's a lot of stuff that has to happen there. The code is it grew organically from 1,000 lines to like 50,000. It needs to be split up. It needs to be refactored a bit to make that happen. But I know this is something Stacy was working on. I've talked with him quite a bit. And he did a lot of talking with Jim when he was still alive about like, how do I get this working under 1.8? And there's a lot of stuff that had to be done, and he's fixed the majority of it. He actually did some work on asterisk 13. It's just basically if we get it working under 1.8 first, then maybe you can port it, but going from essentially 1.4, which is 14, 15-year-old asterisk, to even something relatively modern like 11 or 13, that's just too much of a huge increment to make happen. So 1.8, it's working, and that was actually some of the kind of the newer voice portal stuff that I was messing on was on that. So as for what needs to be done, that's a Stacy question. I'm just a guy with a big mouth a lot of the time here, so I don't really do much development. I bang on things. I do a lot of reverse engineering. I've written some scripts and things like that and fixed problems here and there as I find them, but I don't really consider myself a true C programmer. So anyways, guys, is there anything else before I close this? I'm sorry about the audio initially, but hopefully if you are running on ASL 1.01 on a Raspberry Pi, maybe you can try this out, report back on the mailing list or on some of the forums about how it's working, if it's working, and what problems there might be. Is who? Who is he, Eric? So yeah, Stacy's on the mailing list. That's KG7QIN or something, I think is his call sign. Yeah. Anyways, guys, anything else? I'm going to kind of call it a night here. I think it's about 8:30 my time, so I don't know where everybody else is. Okay, guys. I thought I was going to have to get into more of this. That's cool. Custom distribution on a Pi. Yeah, there's a few of them. If you actually look at the GitHub for AllStarLink, there's some information there about building it. It's actually not that hard. The hardest thing about it is using the older kernel that has the DSP stuff built in. But like I said, Nate's done some patches to DAHDI to fix a lot of that stuff. So the dependencies of Asterisk are really not all that bad. It was all the kernel level stuff that was in part of DAHDI or DAHDI. So that was that was the majority of it. So hey, hope this helps some people. And if you're not a technical person, you got something you can look at. I'm going to publish this. I'm going to try and edit the crap out of the first part of this video to really show people that, yeah, what we've been saying is not just hot air. It's not bullshit. This legitimately, you can take a look at this. Here's 300 bytes and they're identical from one program to the next. The only thing that's changed is the name and the author was deleted. So anyways, 73s. I'll talk to you all later. This is Brian Fields, amateur radio call sign, W9CR.